All right.
Recording in progress.
All right. So this is going to be a review session. It's theoretically pretty quick, and then we can have time for questions. I'm going to start off by showing you everything that we're doing. Do not try to take the notes right now. I'll come back and do them, but this is for the video. So when you come back, if you want to come back and watch the video, the first minute and a half just has the slides real quick, or the writings real quick. So this is chapter 2. Pause the screen and write down what you need if you're doing this on the video. Chapter 3 has wow. Oh, okay. Let me do this. Put that underneath it each time. Chapter 3 is that. We'll come back to that in a second. Chapter 5 is a full tablet. This is just so you can pause them and take notes as you need it. We'll come back and do them in a second. Let's see. Chapter 6 is discrete probability distributions. Again, so you can pause it and take the notes later. Just maybe soak in the content for now. And finally, our normal probability distributions, chapter 7, along with our empirical rule. And I've got all the StatCrunch commands in there, and we'll look at some examples in StatCrunch on how to do each of the StatCrunch things. And then we'll take questions. So let's get started. In chapter 2, we learned about organizing data. We had frequencies and relative frequencies. We took the, like if we were taking a poll of the number of 3.0 or higher students I have in my classes, I could get everyone's input, find their grades. If they have higher than 3.0, it's a yes. If it's lower than 3.0, it's a no. Just add up all the people. That would be n. N is usually our sample size or stuff like that. And x is the people that meet the criteria or is considered a success. So in this case, x would be the total number of people that had a higher than a 3.0. We will do stats, tables, and frequencies to find that. Another way to kind of get that information is with a graph and a bar plot. Bar plot and pie charts are both two ways of showing this kind of data, and they each have the same subset of options, with summary and with data. If you actually have all the data entered in, like I do over here, then we would use with data. Otherwise, you'll have a input from maybe the homework problem or so forth like that, where you just have a summarized data and you would use summary for that. Another thing that looks similar to bar plots are histograms. They look very similar. The types of graphs we had in this group that we work with are basically uniform graphs that, like, all the boxes are pretty much the same height. Skew right is when there is a large hump on the left, but there are some outliers on the right, or at least something that's got a high value on the right that gives it a long tail on the right. Skew left, most of the values are higher up, but we have some values that are low. And then bell-shaped is a nice little well-rounded hump. It looks like a bell. We can take a look at doing these things in StatCrunch real quick. So we'll go stats, tables, frequency. Maybe we'll do gender. Good idea to leave it on frequency and relative frequency. You can do order by however you wish. Value ascending is usually fine. And it gives us a table. It tells us the frequency. It gives us the total number. Up here it says count, 213. And the relative frequency is each of these numbers divided by the 213. So again, that was stats, tables, frequency. Another way to get data that's similar is we could do a graph with the bar plot And we've got the data, so I got to say with data. And we were doing gender, so I'll go back to doing gender. And I'll do relative frequency on this one. So it gives a nice little thing. If you put your cursor over it, it'll show it. Show the values. You can also, when you're doing this, do the display value above bar. And then it'll show only the 3 decimal places. Options and edit allow you to change a lot of stuff if you don't like something you did. Say you wanted frequency instead. Move this over here. And maybe we'll move it across the top. There we go. And then you could also look at it as a pie chart with data, and we'll do gender again. I like pie chart because it gives me the total for each category and the relative frequency as a percentage, not a number. It just doesn't give me the total count. But I could get that by adding these 3 numbers up. So it's kind of useful too. We also talked about, for this section, stats and histograms. Did I? What the hell is a histogram?
It's under graphs.
Did I? Yeah. All right, I need to change what I wrote over here. Thank you. Yeah, I was thinking it should be graphs. Oh well, the beginning part of the slide is wrong. Or the video is wrong. So we'll do graphs and histograms. Thank you. Oh wow, we can't do age. Let's do, or we can't do gender. Because histogram requires numbers, whereas bar plot doesn't. So maybe we'll do shoe size. If we tell it what bins to use, we can pick them. Otherwise, it picks its own. And in this case, for shoe size, it picked a bracket of 1, which isn't bad. Okay. That's some reminders of how to get that stuff and access it. Then we had numerical summary of data. In this section, we learned about the mean and the standard deviation and variance. Remember when we have English letters like X, bar, and S, these represent samples. And when we have Greek letters like mu and sigma, they represent populations. The formulas are pretty similar for the mean, identical for the mean, other than we use lowercase n for sample size and capital N for population size. That transfers over here as well. We have capital N on bottom for standard deviation, n minus 1 here on bottom for standard deviation for a sample. We're not going to do any of that by hand though, because we have stats, summary stats, and columns. We also did the 5-number summary box plots. The 5-number summary is composed of the min, Q1, median, Q3, and max. These are all available in stats, summary stats, and columns. So is IQR. But lower fences and upper fences, we had to calculate by hand. It doesn't do it. Graph box plot will show it, though. So let's take a look at some of those. First stats, summary stats, columns. You can do rows if the data is organized by a row where like each person was one column, and so going across rows was responses. That is not a normal event. Normally we like to do like individual entries as each line going down and responses going from left to right. So columns is the common one. We looked at shoe size. Let's do shoe again. So we've got n, which is the total number of entries. Mean is what we expect, the average. Variance is the square of standard deviation. We'll touch more on variance later. Standard deviation is the one for population or samples. Sorry, samples. Nope. Yeah, samples. No, this is populations. The one that says hold on, unadjusted would be that one. This is samples. Samples is this one. The one that says unadjusted standard deviation is populations. Since everything we do is pretty much samples, they make the top one the most common one. And since they did have different formulas, as we saw, with the n and the n minus 1 on bottom, they did need different entries for it. So we've got, those are the common ones. The 5-number summary has the min. Q1 is probably below, median, Q3, and max. You can see IQR here. And range is the largest number minus the smallest number. So let me click cancel and redo this and just pick the ones they have default. Okay, range is the default, as a default. So if you just run it, you will find a lot of the information you already need. Remember to check on rounding. Each problem is going to have a different requirement on rounding. You got to check each time. Hopefully you've learned that lesson the hard way. Well, hopefully not the hard way, but more than likely you've learned that the hard way already doing homework. The range is the max minus the min. So those are the access to this summary stats. We will use those a lot later in the course to find numbers that we will use in hypothesis testing. So it's good to remember that how to get this: stats, summary stats, and columns. We did talk about the box plot. That's something else that's in this section. We'll do shoes again. You definitely want to have fences to identify outliers, and you want to draw boxes horizontally so that they're a little easier to read. If there is a dot or an asterisk, it is an outlier. In terms of the box plot, it means it's outside of the fences. It is a data entry that is outside the fences. So that's just taking a look at the box plot. If we have a long tail on the left, it's skewed left. If we have a really long tail on the right, it's skewed right. This is almost a perfectly balanced bell shape. There's just one outlier. And that motherfucker got a shoe size of 16. I didn't even know they made shoes up into 16. Good God, that's a big foot. God, that's a foot and a third. 1 foot 4 inches. Good. Well, hold on. Shoe size is not necessarily inch size. I wonder how big a 16 shoe size is. I'll have to look that up later. Come back to our pictures. That kind of covered what we need to know for chapter 2 and 3. So chapter 5 was the long one. It was on probability. Probability, looking at how it's calculated, it's a proportion. So it looks a lot like relative frequency. You count up the total number of things, and that goes on bottom, and then you count the number that it applies to, and that goes on top. Very much like relative frequency. The difference between probability and relative frequency is what has happened in the past. Probability is the odds of it happening again in the future if we pick one more. We've talked about the law of large numbers. As the total number of trials goes up, the proportion, this proportion right here, approaches the true probability. This is handy in cases that we can't like calculate the true probability by hand because it's not something that is known. We looked at Past the Pigs and when we did this section on 5.1 or 5.2 when we were talking about it on Wikipedia. The pigs don't land the same, and so you can't calculate probability. But if you do, 20,000 trials, you got a lot. You got a lot of data, and doing one more trial doesn't really affect the results that much. Some good rules to know about probability. Each probability has to be less than 1, but it's got to be greater than 0. We need a decimal for all of them. And if we add them up, they need to equal 1. We had the general addition rule. This was when we were adding things like when we did it in lecture, it was on Monopoly, rolling in doubles or rolling 7. So when we have an OR situation, it usually leads to, OR leads to plus. These go together. OR goes to plus. This is the general one. The probability E and F is when there is overlap between E and F. That should say between. That's terrible looking. In the case of the examples I just said, rolling doubles or 7s, there is no overlap. So this thing can often be 0. So, but it's not always. Okay. So like this is the one a lot of people learn when they are in high school and stuff like that. This is less useful because they always forget about this one. If you just memorize this one and know that this is 0 sometimes, you've got it covered. Complements are when we have two mutually exclusive outcomes, like rolling a 7 or not rolling a 7, drawing a red card or drawing a black card, drawing a face card or drawing a non-face card. When there are only 2 options and there's no overlap between them, those are mutually exclusive events. And the probability when we add them up equals 1 because there's only 2. We call these complements, and we can write it with a C as a superscript above. So A and B, or A and A complement, B and B complement. We use this a few times. This is used a few times, like when doing later on in the binomial probabilities and stuff. Sometimes doing 1 minus P of 0 is easier than probability of at least 1. That should be a 0. And that should be a P. So calculating probability 0 and then subtracting from 1, definitely a lot easier than doing at least 1 where you got to do them all. We could have events be independent or not independent, effectively dependent. When they're independent, they do not affect each other. Like if I roll 2 dice, what I roll on the first die does not affect the outcome rolling on a second die. So finding the probability and turns into multiplication. When there is a dependent event, like if we draw 2 cards from a deck and don't put them back, after we've drawn the first card, the deck is different for the second card. It's changed, so probability has changed. And that's what this means right here. That is F given E. F given E So like saying E has already happened. Like drawing two clubs. The first club, there's 13 clubs out of 52. We draw the second one, there's only 51 cards left, and only 12 of them are clubs if we drew a club the first time. So a little reminder, maybe that should jog a memory of some of the problems that you did, where the numbers went down on top and bottom. We also had combinations and permutations. Permutations was where order mattered. It was like winners in a race, first place, second place, third place, or like a raffle drawing. You very much want to win first place. So order does matter. When order doesn't matter, like pizza toppings, it doesn't really matter what order you put the pizza on, toppings on for. Other than you need to put sauce on first and then cheese. Don't be a freak. These have two different formulas. If you can find an app on your phone that has these, cool. Otherwise, I recommend just a good old regular calculator that you can buy for $7 or $8. They have them. My calculator has NCR and NPRs above it. And they both have the factorial, which is right above this number right here. Some calculators say PRB. And then you will find NPR and NCR inside of those. Non-distinct objects is where we didn't have, like, if we just had 5 red balls, 6 yellow balls, and 2 green balls, we could figure out how many different combinations we could do using this non-distinct objects thing, where you just do the numbers. The total number is n. That's a factorial on top, and then you do little factorials of each individual group below it. So I said 5, 6, and 2 balls. That's 13 balls. I would have 13 factorial on top, 5 factorial, 6 factorial, and 2 factorial on bottom. This was a long section. There are several problems on the test from probability. Then we had our discrete probability distributions. Expected value is the mean of some stuff. Discrete means it's whole numbers. It might have a decimal, like if we're talking about money, $3.01. It's got a decimal, but it's still technically discrete because it doesn't break down any smaller. A half of a penny doesn't make much sense. We did this with stats, calculators, and custom, and you had to type in x and p of x. And it just takes it and multiplies the x times the p of x and adds them all up. We did this with the life insurance. Life insurance problems were in this category. Example we did in class was roulette. And the outcome you get is from the stats calculators custom is the mean. So if we look at it, oh, rude. Stats calculators customs down at the bottom. You need to values is where x goes, and weights is where the probabilities go. Okay. We also did binomial distributions. It required 4 different things to be true. You needed a fixed number of trials. The trials had to be independent. They couldn't affect each other. There had to be 2 outcomes, and they had to be mutually exclusive. So like yes or no, true or false, 7 or not a 7. And the probability had to stay the same for each trial. which is kind of makes independent trials and a B and D go together. If the trials aren't independent, the probability is changing between them. It goes kind of together. Here you do stats, calculators, binomial. You need to know N, which is the sample size. X is the number of people that are meeting your criteria. And P is the probability. We can find the mean using N times P. And we can find the standard deviation with doing N times P, then times 1 minus P, and then taking the square root. If they ask you what about N and P, what they need to be, we want N times P times 1 minus P to be greater than or equal to 10. This often leads to N is higher than 40, ideally. We can look at an example of that with the data we have. We just got to get some information. Let's do, what the fuck? Why does it keep changing like that? Rude. Let's do stats, tables, frequency. I'm going to get the genders again. I don't remember where they are. So female, we have 126 out of 213, and that is the probability. So I'm going to write this down and I'll switch back over to it real quick. I've got P equals 0.59. I'll just leave it at 59. It's not 100% accurate, but it'll work. And we had 213 people. So we found the probability, or the percentage of people that were women was 59%. Let's say we don't draw 213. Let's say I picked 20 people out of the people that responded. So I picked 20 people, and I want to know what is the probability that X is 12, and probability that 9 is less than or equal to X, less than or equal to 12. Maybe a range of numbers. We'll take a look at those real quick. We'll come over here. Oh my God, I'm going to just start punching some fools. So we had stats, calculators, binomial. I will enter probability is 0.59, and we had N equals 20. If we wanted X equals 12, we could just pick the equal sign. And it gives us the value. If we wanted a range of numbers, I wanted between 9 and 12. Remember, you can't change the sign on the between, so you got to make it match up. But I can see visually that it's matching up. This is 9, this is 10, this is 11, this is 12. I've got the right numbers. So you can always check the numbers by looking at it there, which is handy. Poisson distributions. Poisson distribution, the problem will tell you usually it's Poisson. You will do stats, calculators, Poisson. An example we did in class from the homework was the hurricane one. We also did the insect filth in Hershey's and chocolate. So you'll do stats, calculators, Poisson. The mean is just lambda times t. And the standard deviation is just the square root of the mean, which is pretty handy. Maybe if I do this, it won't change. Oh, good, that worked. Stats, calculators, Poisson. You need to know the mean. That's the lambda times t. In the case of the hurricane, it was the number of hurricanes over however many years they said. And then you're just changing these. Remember when the arrow on this points to the left like this, it means less than. If the arrow points to the right, it means greater than. It means the number on the left, or the value on the left, is greater than the value on the right. That one means the value on the left is less than the value on the right. It's kind of like an alligator's mouth. It wants to have the better meal. It goes after the bigger number. The line underneath it means include equal signs, or include the equal amount, but also do the greater than, or also do the less than. Those are the different options there. On chapter 7, we had normal probability distributions. This is probably one of the most important sections for the rest of the semester. Binomial, chapter 6 comes up a lot too with a binomial. But chapter 7, by far the most important chapter of them all. We will use this stuff a lot. We have stats, calculators, normal, and StatCrunch. You need to enter the mean and the standard deviation. It defaults to 0 and 1. When it defaults to that, if you use that, it's called the standard normal. Remember that we did z-scores. Z-scores was the value of the individual person minus the mean and then divided by standard deviation. It comes from mu plus z sigma, where z is the number of deviations. And it relates to the empirical rule table. So, like, this would be z equals 1, that line right there, because it's 1 deviation, mu plus 1 deviation. This line right here is mu plus 2 deviations, z equals 2 here, and z equals 3 here. In the middle, we don't add any, z equals 0. And then they go down by 1, going to the left. And then negative 3 there. The empirical rule. You should hopefully have this table memorized. It comes up enough that you kind of want to have it available. I mean, you don't want to have to go looking for it when you've got a limited amount of time for a test. Within 1 standard deviation is 68%. Within 2 is 95%. And within 3 deviations is 99.7%. We can see the sub percentages here. A lot of problems had you figure out where these numbers were. They would give the mean and standard deviation and ask how much is between A and B. And so A might be here and B might be over here. And so you have to kind of do that by hand. These numbers do not match up what you get from the stats calculator's normal. They were close. You really want to stick with the empirical rule for questions that specifically state empirical rule, or they give you a number of standard deviations that's an integer. 1, 2, 3, -1, -2, -3. If you have something else, you want to use stats, calculators, and normal. And let's go look at that. So normal, it defaults to 0 and 1. An example I like to go with is the IQ test because I know the values. The mean on the IQ test is 100. Standard deviation is 15. And you could either do less than or greater than. Let's say greater than, what's genius, 132? A very small percentage of people categorizes in the genius category. Most people are between 85 and 115 because that makes up one deviation. Note that when we do the normal calculator, it does not default to the 68, 95, 99.7 ticks when mean and standard deviation are not 0 and 1, but we can click on this button there and make it that way. So if you're working on a problem and they want you to do this empirical rule thing, and you don't want to take the time to like add the standard deviation to the mean 3 times and then subtract it 3 times, you could come in here and put the mean and the standard deviation and click on this 68, 95, 99.7. For problems involving the empirical rule, you do not want to use this as a result though, because it has that extra stuff. 68, it should be 68%. 68% doesn't quite do the full value. When we do 95% would be 70 and 130 here. That's 2 deviations. Notice the this as a percentage is 95.4. So when you're doing empirical rule, you have to use the values on this table. It's not 95.4, it's 95. And other than that, I think I kind of hit on every major topic that we used. Do we have any questions? Like, I'd rather give you more time to practice the midterm. The midterm review is up through, let's go look. Seems like pretty important. Midterm review is up through tomorrow night at midnight. It will not be up afterwards. So I would go through it now and like if you can tonight or sometime tomorrow, go through it, try to answer them in the time allotted. And if you're smart, right? If you're smart about it, write down the questions you get and how you solve them. Okay. I do not have classes on Wednesday night. So if you have questions and need to Zoom with me to ask me some like last minute stuff, like I did the midterm review and I don't know how to do this, contact me and we can arrange to meet tomorrow evening. And I can even answer like the midterm review won't be up after the midterm starts on Thursday. But if you have questions and I'm not looking at the review, or I'm not looking at your actual midterm on the screen, I'm happy to answer questions on other days of the week. This Friday, I am leaving to Oregon at like 8 in the morning, and I won't get there till late. If I have time to log in Friday night, I will for Zoom, but I don't picture that happening. We're doing my mom's funeral on Saturday, like spreading her ashes in the lake kind of thing. It's been 6 weeks. A lot of us, the emotions are toned down a little bit, so hopefully not a cry fest. And then I'm coming home Sunday. So Friday and Sunday are pretty busy. The whole weekend's busy. But again, the midterm's due on Tuesday at midnight. So you don't want to wait till midnight, or do not wait till Tuesday to do your midterm. Don't be a fool. You wait too long, the internet goes down, you're SOL. You're like, I'll get an email. My internet went out. I guarantee you, one student in Got about 110 students in my stats classes right now. I guarantee someone's going to email me on Tuesday and say their internet went out and what can they do? And I'm going to say you should have spent the time in the last 5 days doing the test. Thursday, Friday, Saturday, Sunday, Monday is 5 days that are not Tuesday. Got plenty of time. I will be back on Monday or Sunday night though, so if you have questions, I might be free Sunday night to hop on Zoom and email or talk. I'll definitely be free Monday afternoon and evening to answer questions. And we'll go from there. We have a new section. We're doing a new section on Tuesday. So even though I normally had the midterm due on Sunday, and I decided I'll just give it till Tuesday night to give people more time. I think that was a bad idea. I think next semester I'm not going to say Tuesday night. I'll say like Monday night. Because then I got students waiting until like class, trying to do it in class. Any questions?
I have a question from the midterm review.
Yeah.
There is a question on there that reads, find the probability of the indicated event if P of E is equal to 0.35 and P of F is equal to 0.35. Find the probability of E and F if P of E or F is equal to 0.45. So it's like
Okay.
find P of E and F if P of E or F equals this.
Let me write some numbers up, or write your numbers down and talk about it.
Okay.
Tell me what they were again. What was probability E?
Probability of E is 0.35,
Probability F?
0.35 as
Oh,
well.
identically. And they had probability of E or F was 0.45.
Yes,
And they wanted to know probability of E and F.
correct.
Okay, remember we had a formula for this. Probability of E or F equals probability of E plus the probability of F minus the probability of E and F. And we can fill in almost every single thing here. I got 0.45 here. I've got 0.35 plus 0.35. This is the only thing I don't know. I'm just going to say P. I don't want to write the whole thing again. If I add these up, it's 0.7 or 0.70. And you could subtract 0.70 from both sides. And on the right side, it goes away. We're just left with P. Nope, that was a negative P. This negative matters. I got a negative P. On the left side, 0.45 minus 0.70 is negative 0.25. And at this point, we can cancel out the P's. So P, or cancel out the negative signs. P should be 0.25. Does that make sense? Oh, that's a good question, Paige. Let's do that one. So Paige sends in chat that a professor has 20 students and he can't read all of their grades. I've had this happen, believe it or not. I don't remember what was the event was, but it was very similar to this. It said the mean of the 19 readable ones is 84. So mean of the 19 is 84. And the overall mean was of all 20 was 81. They want to know the value of the missing one. So, the overall mean should be person 1 plus person 2 plus, I don't know what the 20th letter is. Let's see, Z, Y, X, V, W, Z, Y, X, W, V, U, I don't know, T, all the way up to T. I think that's the 20th letter, I think. All divided by 20 would give us the mean, and each one of these is a score. Let's say we don't know the A, though. So that's what we're trying to find. What is A? Well, when they give us the X bar is not for the 19 is 84, we know that of the B plus ... through T students over 19, that has to equal 84. That's what the mean formula says. Adding up the other 19 students, dividing by 19, I get 84. I can figure out this value right here. Even though I don't know what they are individually, I can figure it out by using this. I can multiply 19 over. So that equals 84 times 19. Yeah, let's see what that is. Oops. I wrote plus. That, and I deleted too many that time. 1,596. So I'm going to rewrite X bar. I've got A plus 1,596. I'm just replacing that right there. Over 20. I know that has to equal 81. So I can do something similar. I can multiply the 20 over, get rid of it over here, multiply by 20 over here. I got A plus 1596 equals 1620. And now I can find A by doing a little bit of subtraction. Looks like 24. He was bringing the mean down. And that makes sense. If we add his score in and the mean drops, and it dropped by a lot, 3 percentage points for dropping the mean for one student means that student was a lot lower than the average score for everybody else. So he or she had a very low test score, and 24 would fit that. Another way of doing this is a terrible way of doing it, but I'll show you. Let's bring StatCrunch back up. Let me make a new table. So I knew the average of the 19 students was 84. I'm just going to enter 84 19 times. I don't know what their individual scores were, but this will simulate it. And if you don't believe me, we will do a quick it's over there. Move that bar up there. So the mean's 84, and then I don't know what the other student got. I could just start plugging some shit in. So let's say let's guess the student got 100, and I can recalculate. Nope, that's not what I wanted. The mean's too high. I need to go a lot lower. Let me try going down to 70. And I could keep doing this until I get to the value I want. Notice 25 won't get us quite there, but it'll be close. If I change this to 24, I could do it. That's trial and error. I think the other way is a little bit easier. All right, Natalie's next question is one of the, it's kind of like the broken TV problem. There's also diet sodas versus regular sodas. So in her question, she had a 12-pack of soda. Let me bring up that back up. We had a 12-pack of soda, and it said 4 cans of regular were accidentally filled with diet. So there's 4 diet cans in there. This was regular soda. That means how many do I have that are regular that are left? I have 12 minus 4 is 8. So 8 regular cans and 4 diets. And it says, suppose that 2 cans are randomly selected from the 12-pack. Determine the probability that both contain diet. This is like what I was showing you with the 2 clubs. Get another pen color over here. Both diet would be, this is the probability that the first is diet plus the second is diet given that the first is diet. And plus means like and. And turns into multiplication. Probably the first is diet times the probability that the second is diet given that the first is diet. Well, the first one being diet, there are 4 cans out of 12. The second can being diet, there are only 11 cans left in the 12-pack, and only 3 of them are diet. And you find it that way. The harder question in there is the one where it says exactly 1 is diet and 1 is regular. I think that's the last subset of the question. Remember, this could happen in 2 orders. I could do my first can is diet, and my second can is regular, or I could do regular and then diet. So 2 equals R given 1 equals D. Or, either one, the first one is regular, and the second one is diet given that the first is regular. So the or turns into plus, the and turns into multiply. Probability that first equals diet times the probability that the second equals regular given that the first is diet, plus the probability that the first is regular and multiplied by the probability that the second is diet given that the first is regular. I wouldn't write out this whole equation. I would just do each one separately. I'm just showing you where this comes from. The first one being diet, we already talked about, was 4 over 12. If the second one is regular, there are 8 regular cans in that 12-pack, but there's only 11 left. We pulled out one of the diets. And the probability of the first one being regular is 8 over 12. And the second one being diet, there's 4 diet cans because we didn't draw any out. There's only 11 left. You'll see that these are identically the same. 4 times 8 is 32. 12 times 11 is 121, and that happens on both of them. So you could really just generally do one of them and multiply it by 2. I think you're better off doing this just in case they change some shit up. This is 64 over 121. The denominators match, so I can just add the numerators. So whatever this is as a decimal, it's a little higher than 0.5. 60.5 would be half. So we have 64. It's a little bit higher than that. So that's how we would do that one. That make sense? Did I miss any questions? I got Natalie's question, I got Paige's question, and we did Natalie's first question. If you don't have any more questions, that's it. You're free to go. What is this?
Professor Jones.
I'm sorry, what, Daniel?
Oh, I was just saying, so for the midterm, are we gonna have like is it gonna tell us view an example or no?
No. God, no.
Okay.
Otherwise, it's not even a test. People would just use that. Believe it or not, view an example would be bad. It would slow you way down, and you wouldn't get shit. You wouldn't get half the problems done. It would be if I gave you an example, even for people that knew what they were doing.
Yeah.
You would waste time looking at that you don't have for the overall test.
Okay. How many questions are there going to be on it?
It's less than the review has. I forget how many it has. It's less than the midterm review. So like some of the more difficult ones in the midterm review don't show up on it.
20? Did you say like 20, I think?
I think it's higher than 20. I think it's like 26 or something like that.
Okay. And do we get the extra credit that you were telling about? Like the homework or something like that? Or was that for the final?
It will apply on the homework when the midterm starts on Thursday. On Thursday, when the midterm starts, I will download the scores from my math lab, and I will see who's done more than the percentage of homework. I forget what percentage I said. Let's go look at it.
Okay.
Oh, rude. But I will download the scores, look at everyone's percentage, and those that do, I will give extra credit on your midterm. That is still in effect.
So how does that work again? Like, how would that?
I just told you. I'm going to download your homework scores.
Oh no, yeah, no, but how does like the extra credit work?
I add the value. Like when I'm done, I'm gonna put your scores in Canvas, and I'm gonna add the extra credit points to the score, your midterm score. So what was the percentage I said? I used to do 70%. I think it's still the same. Yeah, 70% of the homework. So if can I show you one without showing you student scores? I don't know that I can. I can add up calculate the total number of points for all the homework, for the 6 homework sections we've done. Chapter 1, 2, 3, 5, 6, and 7. I can figure out how many total points there are, and then it's easy to find out how many total points you've earned. And it downloads it into Excel and Microsoft Excel. I'll just effectively do Relative frequency. I will take your score and divide by the total number of points and multiply by 100 and see if you're at 70% or higher.
So how much are we available to earn of extra credit towards our midterm?
2% extra
2%?
credit. Yeah. If you do
Okay.
the 70% on your homework before the midterm, it's 2% there. The same applies to the final. If you do 70% of the homework for the chapters on the final, you'll get 2%. If you did both, it's cumulative. You'll get 4% on the final, which is a good,
What if we
that's like B plus to A minus, or even an A, B plus to an A minus or A. So you can get a letter grade bump. Or
what if we've completed like 100% of the homework by the midterm? Does that like affect anything towards our score?
well, that's above 70%, so you will get the 2 points of extra credit. Although I kind of like the idea of having students that do more of the extra credit get more points. I might have to think about that. You're at least getting the 2. If you've gotten
Okay.
100% on the homework, you are in good shape for the test. Presuming that you didn't view an example on every single problem and don't know how to do any of it. I have students that do that. There will be students that look through, use view an example on every single one. It's like using tracing paper on every single art assignment and never knowing how to draw. Do they still make tracing paper? Shit.
Like you're calling me out right now.
Well, if you do that, make sure while you're practicing you don't.
Yeah.
Or go back.
Okay.
There's a way you can fix that, Emmanuel. If you go back to assignments you've done or are still working on, when you use view an example, if you feel like this was a difficult problem, once you're done with view an example and you do the problem correctly, don't go to the next question. Click
Yeah, just
similar
do it.
question. Do another one
Yeah.
and don't do it with the example. See if you
Okay.
can do it without the view an example present. It
Okay.
also helps. A smart student would write down the shit they did on the view an example.
That's what I was
So
planning on doing.
if you
Midterm.
really got to a question on the midterm, you're like, I really don't know how the fuck to do this. I don't remember how to do this. If you've been
It's
writing
similar
down
work.
on the midterm or on the review or on the homework how to do stuff like that, you might be able to find it in your notes.
Yeah. Yeah. All right. That was my question.
Let's see.
On chapter 6, like the last thing that we learned, you had it on the whiteboard that
Yeah, the
the
Poisson
whiteboard
distribution.
Yeah. The last part kind of like I don't really understand. It's question 19 of the homework.
Okay.
It's about like the hurricane one. You had mentioned it.
I
It
think
talks
we
about like
did it in
hurricanes.
class.
Did we do it in class?
I'm certain I did it at least at the end. Let me see how. Let's see. Do the questions actually show something?
I don't know if it was last class, then I left to work early. I had left class early to go to work.
Oh, it doesn't tell you which section. Okay. Close that. So homework chapter 6. We'll go look at it again. It's not a problem. Yep, I know I did it because look at that. It's done now.
Yeah, I think I left early to go to work. I left early that day.
Okay. So rather than re-walking through it, because it's like 10 minutes, watch
Okay.
the end video of that one. And if you still have questions, email me and ask. Because I literally walked through how to do like every single part of this.
All right,
Okay.
cool. All right, thank you.
Anybody else?
Thank you. See you later.
Take care, Emmanuel.
Yeah, you too.
Well, if you've got no questions, I'm going to go have dinner. And we'll stop recording.
Recording stopped.
And I will talk to you later.